This is a calculus exam from an Italian university. I was contacted by a student to solve the problems that you see here. Don't worry about the Italian because I will translate the language for you. So I will translate it into English and we will see all the problems in separate videos. So I will start by solving the first one. And as I said, I was contacted by a student to solve the problems myself instead of her during the exam, so I need to send her the solutions. And basically, this is something which is not recommended. It is not something that I can boast about because, after all, I solved the exam instead of somebody else. But my desire to help somebody else after listening to their story, the fact that they couldn't pass this exam, really, let's say, ignited a spark in me, and I wanted at all costs to help somebody else, even if this is something that I do not recommend. And probably I was wrong here. I have to blame myself because after all, I'm not really helping somebody else to learn all the things behind the concepts. I was solving the problems myself, and she just had to copy. So I do not boast about this. I do not regret it though, because honestly, this is what I was asked. I was asked to help somebody else who didn't pass the exam the first time, and this is basically something that makes me feel better because I have helped somebody else, and this person has thanked me. So this is what I want. I want some emotions also while I'm helping somebody else. But anyway, let's keep that aside. That is not the point. That is not the point. The point is that I want to show you the exam and I want to solve the problems here. And we will start with the first problem. The first problem consists in finding the domain of this function here, f of x equal to 4 arcsine, which is the inverse sine of 1 minus the natural log of x minus 1. So we will start with this in this video. Then the next video will, in the next video we will solve the second one. Then there will be a third video, a fourth video, and a fifth video. So these videos will be short because these are not very complicated exercises, problems. Let's say they are calculus problems, and this was an exam. And the university is a university of mathematics in Italy. But anyway, as I said, I want to focus on the problem. So let's start with the first one. The first one, as I said, consists in calculating a domain. And the arcsine function is the following function. So if we want to plot arcsine of x, and here on the abscisses we have x. Now, the function has the following domain. At x equal to minus 1 and at x equal to 1, we have this we can draw these vertical lines, and outside of this, so outside of these lines, here and here, the function is not defined. It is not well defined. So the function is defined only inside the interval minus 1 to 1, and the behavior of the function is something like this. So it will not be a precise sketch. It is just a sketch after all. At x equal to 1, the function is equal to pi over 2, and at x equal to minus 1, it is equal to minus pi over 2. So the domain of the function for arcsine 1 minus log x minus 1 can be found like this. So it means that the absolute value of the argument of the function, which is 1 minus natural log, so let me write it as ln instead of log, because this is the way I'm used to writing the natural log function. I use ln, but never mind. And then here I have x minus 1, and this should be less than or equal to 1. This is how we can define the domain of the function. This basically means that minus 1 should be less than or equal to 1 minus natural log of x minus 1, and then we have that this is less than or equal to 1. And then here we have the following system. So natural log of x minus 1 should be greater than or equal to 0, and natural log of x minus 1 should be less than or equal to 2. This one implies that x should be greater than or equal to 2, whereas this one implies that x minus 1 should be less than or equal to e squared. And from here, you can easily see that the domain of the function is x greater than or equal to 2 and less than or equal to e squared plus 1. So this is the answer to the first problem.